What's up, everybody? Welcome back to the Coding Cleverly channel. This is another weekly live stream I wanted to do, and so I'm going to be talking about some important things. So let's just share our screen. Let's just get right away. If there's any viewer or anything, and any person who wants to leave in some comments or chat things in the chat, then feel free to let them be written down. I'll review it. We're just going through some of the old, posts. I do post some comments in the community forums, and I'm not getting that many responses, and I wish I could. I'm hoping that people respond regularly, or give a bit of feedback. So let's go and see over here. If we go to the YouTube channel, and over here let's go to the community. Here, I just had like one comment or something, and I'm also going to go through some of my own, but briefly talk about SFINAE. This is one thing that one person asked, which was just a random guy. All right, 6794. If the person is watching right now, what I would do is that up front, I would go and research online. So like right, you can see over here, I'm on Google. What is a substitution failure is not an error. Substitution failure is not an error. So is a principle in C++ where an invalid substitution of template parameters is not in itself an error. Valid. David Van de Voorde first introduced the acronym SFINAE to describe related programming techniques. It's a technique. When invalid substitution of template parameters is not in itself an error. Okay, so it's not some kind of, it's something like some kind of concept that might assume to be an error, but it's not. So it's like a substitution. All expressions using the function type, all expressions using the template parameter declaration, all expressions using the template argument list of partial specialization, all expressions using the explicit specifier. So we have a template type name, struct b using type, and yeah, type SFINAE. The following type errors are SFINAE errors. Template. Yeah. So yeah, it looks a little pretty strange. But let's see where we could actually think about this. So leave in your chats or things like that. I'm gonna be looking through this and seeing a really good approach. The rule applies during overload resolution of function templates. Okay. When substituting the explicitly specified or deduced type for the template parameter fails, the specialization is discarded from the overload set instead of causing a compile error. This feature is used in template metaprogramming. Okay. Function. Template parameters are substituted, replaced by template arguments twice. Explicitly specified template arguments are substituted before template argument deduction. All expressions using function type, all expressions using template parameter declaration, all expressions using the template argument list of partial present. Okay, so there's like some if anyone has like a really nice explanation to this, leave it in the chats. Chats are open for any kind of help. Open for any sort of questions. Okay. So yeah, I'm just gonna I'm looking for an update on this. So yeah, keep posting it, and yeah, let me know. So over here, what we're gonna be doing is we're gonna go through AI. We're using AI to learn as well. So what we're gonna be doing is we're gonna say explain what S type is not an error. I don't know if it's like this, but let's see what it is. Yeah, so it's SFINE. Substitution. Okay, substitution failure is not an error. In C++, I don't know anything about it. Okay, explain it from scratch. This is this is the prompt that you should give when you want to learn anything. Now look how easy and beautifully it explains it. So it says SFINAE, substitution failure is not an error, is a concept in C++ that's used during template instantiation. Okay, it allows the compiler to ignore certain templates if they do not match a given set of conditions, rather than treating the substitution as a compilation error. This enables writing more flexible and specialized code in C++. Let's break it down from scratch. What is SFINE? SFINAE, my bad, is in C++. When you write templates, you often write multiple possible versions of a template function or class. SFINAE is the rule that says when the compiler substitutes template arguments into a template and it fails due to syntax error or an invalid type, it won't immediately cause a compilation error. Instead, it quietly ignores that version of the template and looks for other viable candidates. So that's pretty good. You create templates, custom templates. You might assume that you have some kind of issue with some of the declaration part of it, but the compiler would just automatically ignore it and it will just look for other viable solutions. That's what's substitution. What is basically substitution failure is not an error scenario thing in C++. Why is substitution failure is not an error useful? Well, it allows C++ code to be more flexible by letting you write code that works only in certain situations, depending on the types you pass into the templates. Now, you know what templates are. It allows you to have custom types, right? When you create a templated class, it allows you to have a class of any sort of type, and a templated function allows you to have any sort of parameters inside that function. So you could call them a type name, and they basically have, you could actually include any kind of int, Boolean, float, double, whatever, because you have a template that's a custom. So why is it useful? This substitution failure is not an error. It allows more flexibility by allowing you writing code that only allows in certain, but that only works in only in certain situations depending on the types you pass into the templates. It helps achieve compile time decisions from things like function overloading or type checking. Okay. Okay. Let's go through the example to illustrate this concept. Now let's checking if a type has a specific member function. Suppose you want a template function that works only if the type passed into it has a specific member function, say foo. Now what is this checking if a type has a specific member function? Okay. Member, okay. Suppose you want a template function that works only if the types passed into it has a specific member function, say foo. Okay, so we have an IO stream, we have a type traits header file. First, we define a template that tries to detect if a class has a foo function. Okay, so it looks really nice because I'll explain bits and bits of this snippet. First, we define a template that tries to detect if a class has a foo function. So you can see over here, template type name t, and then we have class has foo. And then inside of here, we have use SFINAE. Here, if t : foo exists, this declaration will be valid. So we have template type name u, static auto test int, and then we have this stuff. Otherwise, it will choose this fallback. So type name, and then we have a false type. And we have, this is the, I think by default, the private access specifier, and then this is the public access specifier. So result will be true or false based on whether foo exists or not. So we have a public, inside of this, we have a bool val, okay, a Boolean val, value, constant expression, and then we have dec DCL type test t0 : value. Okay, now if we look at a class with foo, so we have class A, we have a public, we have valid foo, A has foo, and then we have class without foo, we have class B. And then we have int main, and then within the main function right here, we have does A have foo? And then we have has foo A. And then we have does B have foo? So we have has foo B, and then the value. All right. So it's going to give you more explanation to it, but let's just break it up and understand what's going on here, right? Before that, let me just check if there's any questions or concerns. Remember, you have the chat opened up, so you could learn or ask anything over here. Now over here we have that we know that that's used during template instantiation. So let's say, okay, we don't know all of this and we don't know what template instantiation is. I'll say I don't. Now I'm giving a multi-turn response, right? I'm giving another prompt to the already existing prompt and response model. So this is a regret. This is basically called so there's a search engine, and this is another engine, which is called, there's a term for this, reasoning engine. There you go. So this is called a reasoning engine. So I don't know what template in C++ is. I'll say I'm a beginner and really want to understand this concept. Please explain it well. Now, I'm going to press this, and let's see what it comes up. Templates in C++ are a powerful feature that allows you to write generic and reusable code that enable functions and classes to work with any data type, making your code more flexible and reducing redundancy. Let's dive into the concept from the basics. What is a template? Template is a blueprint or formula for creating generic functions or classes. Instead of writing a separate versions of function or class for each type, we have int, float, string. You write one template that can handle all types. That's amazing. A hybrid class, right? A hybrid template. So there are two types of templates. There's a function templates and class templates. Now, function templates allow you to write a function that can work with the data types. With any data types, let's start with an example to explain this. Now, without templates. Now, without a template, you don't have to write every single thing with different things. Like you can see over here an example. Suppose you want to create a function to find the maximum of two numbers. Normally, you would write a function, separate function for each data type like this. So you would have to write two functions. And so for the int data types, you would have to write int max int. And then for the double data types, right, you'll have to write max double. So this is what, it's kind of weird. You have this really nice ternary operator. So I have two input parameters, A and B. We have this thing on the first. We say while if A is greater than B, if it is, what we do is we put this question mark and say whatever is in the first case, that's true. So if it's, let's suppose this is 10 and this is 5. If 10 is greater than 5, then obviously A will be printed out, or it would say true. Otherwise, it will be B. So this is just a shorthand way to say it. Max double is just 2 again. You have 10.0 as well as 5.0. Right, or 5.5 and 10.5, and then you would still compare and see that 10.5 is greater than 5.5, and you would just return 10.5, right? You could say if that is there, then that's true. Otherwise, this is false. That is fine. But what do you want to? But what if you want to find the maximum of other types like float, long, and char? So you can see over here, this is just for doubles and ints. But what if we wanted to use it for floats, long, or chars, right? You'd have to write a new function for each type, right? You'll have to write more and more functions. This leads to repetitive code. Here's why templates help. Now, here's where templates help with function templates. Using a function template, you can write a single function that works for any data type. That's amazing because look at this structure of it. So we have a template definition, and in the definition, we have a template keyword, and then we have angle brackets, and we have type name T. You can write this letter as anything you want, like T, K, P, L, M, N, O, whatever you want, but I would just put in capital T because it's just a more of a tradition and a more it's just more, used, so type name T, and then within this, we have a return type of that same exact type name T, meaning like any kind of type, universal type, okay? And now remember, when you have this function name, like over here we have this max name, we already have a return type like int or double, right? But as a universal type, what we created over here, T, we'll just have that T over here. And guess in the input parameters, you would have an A and B, right? But the return types would, the return type here would be T, but over here, they're inside types, your data types would be T's. and then with again the same sequence, but now it works so flexibly. And look at how awesome that looks. I'm calling this, I'm invoking this same exact function with integers, and it's gonna work with integers. Um, and when I'm going to be working it with doubles, it's going to be working with doubles. And I'm going to work it with chars, it's going to be working with chars. Now, how it's going to work, I mean, how it's going to tell if it's a maximum within chars. You know the ASCII table, the lowercase a is 97, and the lowercase z is somewhere all over 97. So 97 plus 26 letters, I believe, and then whatever that is, you'll see ASCII-code, I guess, .com. I don't know if this is the website, but it shows you the ASCII table. And yeah, so I was looking over here when I was like saying, okay, so over here you could see over here symbols, and if you just mark it down, you'll see the capital A's right here, and yeah, it's uppercase A, and yeah, it's 65 here. That's the code. But when we look at lowercase a, this is over here 97, and then lowercase z is over here 122, right? So that's essentially there. You know, what is more bigger than this? 122 is bigger than 97, right? So z will be printed out. Again, template type name T. This line includes a template, the keyword template. Template type name T. This line defines a template, right? Template type name T. This defines a template. This top over here, right? The keyword type name or class, which is interchangeably here. Now the keyword type name. Oh yeah. Now the keyword type name or class, which is interchangeable here, introduces a placeholder for the type. T is a placeholder type that will be substituted with the actual type when the function is called. Now, so this is, the top, it defines the template, the keyword type name or class, which is interchangeable here. Introduces a placeholder for the type. So basically, this is introduces the placeholder, and this is your placeholder value. And then Tmax, this is the function definition. The type T will be replaced with whatever type is passed into the function when the function is used, like int, double, or char. Used when you call max37, the compiler automatically replaces T with int. When you call max3, the compiler replaces T with double. The function template allows you to avoid writing separate functions for each type, and makes the code more maintainable. What is class templates? Just like class templates allow you to write a class that works with any type. That's also very powerful. Without templates, let's say you want to create a class to store a pair of values. You might write one for int and one for double. So when we have like an int pair class, we'll just have like public section, and inside of it would have an attributes. So it would just be x and y. And then we'd have this function int pair. It's a constructor and has input parameters a and b. And it sets the value of x to a. This is another syntax way when we're looking through C++ 11, which is the version in C++ 17. More and more when you go upgrade it with C++, it just makes the syntax more cleaner and cleaner. So this is a really elegant way of instantiating it. So this is a constructor. You could call it as a parameterized constructor, and within the body, this is the body. And what it does, it's actually, this is the body. It's just like written like this. The x value will contain a, whatever a is passed in, and the y value will contain b. Okay, and then the same goes for double pair. We have x and y, and we have a and b, and same things. Again, this is redundant, especially if you want to create pairs of other types, right? So we'd have a double pair. I want to have an int pair, and you could see the types are being interchanged, and this is becoming redundant if I want to do it for a double or a float pair, and then I want to do it for a string pair, right? So with class templates, this solves the problem. Here's how you can use a class template to generate a pair class for any types. So what we do is we'll use the template definition. Again, remember, like on the top over here, this line defines a template. So this thing, template type name T, you'll see template type name T right on the top of the class, right? And then would have a class pair, and inside the public would have a tx and y. You could put them inline, or you could just say tx and then semicolon, and then in the next line you could say ty semicolon. T is a placeholder for the type, but you could also do it inline and just write whatever attributes you want. But now look at this; it's more flexible and more generic, where you have get first, you return the X, and you get second, you return the Y, and then you can see the return types as in T, just as the placeholder for any type. And then what you would do is over here, it's public. So what you could do is you could create instances of the pair class. So we would say pair of, okay, pair of int. Okay, is there like a, yeah. So we'd have to do an int pair. Okay, int pair. Okay, so we'd have a pair. Okay, you can see how I instantiate this. We're gonna use the class name over here, and inside this, inside of these angle brackets, we'll put the type, specifying it. So when we'll put int, meaning that when we say int pair, so we'll call the object. This is the object name. Sorry. So this is the class, the type, the object name, and then within the the constructor that we're calling right here, and we're putting in the numbers, right? A pair of ints. Again, the class, the type, and then the object name, double pair, all right? And we'll put 3.14, 2.71. All right, and the last one is class, type, object name, right? Object name is char pair, which is essentially a name that you created, and you have to put in two values, and you put in A and B. Okay, so now you could do int pair, and then you say get first. It would give you the first and get second, and then the get first. So it would just work all the way, right? So it's generic. It's super generic. Template type name T, just like the function templates. T is a placeholder for a type. Class definition inside the class. We use T to declare member variables X and Y, and member functions with get first and get second. These are member variables. Okay. Uses when we create pair T, the pair int. So what happens when we create pair, the compiler replaces T with an int, right? For the pair double, it replaces T with double. It all the same kind of concept going in. The same class pair can now be used with different data types without writing separate classes for each one. Okay, the same class pair can now be used. What's it saying? The same class pair can now be used with different data types without writing separate classes for each one. Now you understand just one universal class, which is a template one, and it could be used with different data types, right? That is the concept of it. Yeah, key concepts in templates. Template declaration, you can declare a template with the template type name T or template class T. That's what I was saying, like interchangeably. You could use type name or class. It would still work the same, right? Type substitution, when you use the template by calling a function or creating an object, the function replaces T with the actual data type. That's all. Generic programming, templates enable generic programming, where you write code that works with any type, promoted code reuse and flexibility. This is the advantage of it. Code reusability and flexibility. Template specialization, this is another concept of template specialization. So we're going to be going through the template specializations, just heading over to the chat and seeing if there's any questions. Hey, yo, what's up, guys? Nice if you're enjoying this video. Let your questions being asked here. I'm going to be trying my best to answer all of them. And so far, if you have any more questions, right, just leave them in the chat. So we're going to be exploring each and every concept with the help of AI in this video. So over here, we have template specialization, right? Sometimes you might want to handle specific types differently. What do you mean by specific types differently? Template specialization lets you define special behavior for a particular type. Here's an example where we specialize the max function for a char to make it case insensitive. Now, okay, there's a lot of things here, but let's just break it up. Break it up and say, what is template specialization, right? Now you want to sometimes you might want to handle specific types differently. Like you have a universal template class or a universal template function, but sometimes you want to have it handling specific different data types differently. Template specialization lets you define special behavior for a particular type. And here's an example where we specialize the max function for char to make it case insensitive. Now, case insensitive meaning sometimes case sensitivity means like, okay, there's a lowercase a and a capital A, right? Lowercase a is 97 in value, whereas capital A is 65 in value. Sometimes you want to make it case insensitive, but despite having been lower or upper, you just have made it, when it's A, I don't care if it's an A, capital A, or it's a lowercase a, it's just case insensitive, right? So this is the specialization part where you want. Here's an example where we can specialize the max function where it does not matter if it's a capital or a lowercase a. What we could use is a template type named T, Tmax, TA, TB, return A. No, okay. Remember, right over here, we have this specialization for char. So this is the specialization that's defined afterwards. You'll have the same thing up on the top. This is the function, right? The function template. And inside the template, you have another specialization for char right underneath, where we rewrite template keyword, but in the angle brackets, we don't write anything. And we write a chars explicitly with the max function, and then we're writing the char A and char B. And then we use the toLower function method. This is defined in C++. You could add it. And then you say toLower A, and then we have greater than toLower B, and then we have A and then B. Now this is case insensitive comparison because it's only going to be comparing with the lowercase alphabets. If I have like a capital A, if I have one capital letter and I have another lowercase letter, they're gonna both be first converted. Or if I have both uppercase letters, they're first gonna be both converted to lowercase and then they're gonna be compared, right? That's called case insensitive comparison. And then we have, if we're using it for integers, it's gonna use its generic template, you know, this one. But when we're using it for chars, we could use a capital A and a Z. What's it gonna do? It's gonna verse lowercase it because we're gonna use our specialized version of our template. It's gonna detect that we're using chars. It's gonna lowercase this a to a small a. It's gonna make the lowercase. It's already z, so it's gonna be lowercase. It's gonna check if a, which is 97, is that greater than what's 122, I believe, which was lowercase z. So it's over here. Lowercase z is 122. So no, z is bigger. So that's why it's not gonna run this, but it's gonna run this part, right? And that's how this specialized template specialization works. Benefits of templates: code reusability, type safety, avoid redundancy. You know, you only write one generic function class, which can work with any type. Type safety, meaning the compiler checks the types at compile time, ensuring your code is safe. It only checks the types at compile time, and in the runtime, it all works for you. Avoid redundancies. You avoid writing the same function or class multiple times for different types. Again, it's reusable. Okay, summary. Templates in C++ are a way to create generic reusable code that can work with any data type. Okay, you can define both function templates and class templates to handle operations generically across various types. When you use a template, the compiler substitutes the actual type of the template's placeholder. T in our example, templates greatly improve the flexibility and maintainability of C++ code. And that's how we basically understood the concept. I don't know how confident are you after reviewing this whole, prompt response from, the AI model, the LLM model, but it did bridge the gap of, what we didn't know about templates. Now what we want to do is add on top of it, right, to that original question that we had. Just before that, I'm just going to reread the summary. If you have any questions, throw it in the chat. I'm going to look through the chat again. But we're going to be solving the answer, and then hopefully, if there's any more problems, you could throw it in the chat. But yeah, templates in C++ are a way to create generic reusable code that can work with any data type. You can define both function templates or class templates to handle operations generically across various types. When you use a template, the compiler substitutes the actual type for the template's placeholder in our examples. So essentially, it's what templates greatly improve the flexibility and maintainability of C++ code. Essentially, what it's saying, whenever you use an actual type for the template's placeholder, if the compiler would just substitute it. That's what it's saying. The compiler has this powerful ability to substitute it. Okay, so that was all good. But then I want to know, this thing. So I'm just going to copy this, and I'm going to go all the way down, right? Right. So we're going to say, explain what sfinae in C++ is. Okay. In C++, I don't anything. Sorry about that. I don't know anything about it. Explain the script. Oh man, I did so bad. But you know, the LLM still understands our prompts. Um, so you know, you don't need to worry about that. Explain from scratch. Since I just learned about templates. Okay, just say all that about templates. All right, in C++. Okay, so now let's check this out. Great. Now that you've learned about templates in C++, let's move on to SFINAE. What is SFINAE meaning? Which is a more advanced concept related to templates. What is SFINAE in C++? Stands for substitution failure is not an error. It's a rule in C++ template programming that allows the compiler to fail to substitute a type in a template function or class without generating a compilation error. Instead, the compiler simply ignores that particular template and tries another one if one is available. Okay. In simpler terms, what it says is that when the compiler tries to match a template to a specific function or a class call, it may fail to substitute the types you provided into the template. If this substitution fails instead of throwing an error, the compiler silently skips this template and looks for another one that works. So this is what I'm saying behind the scenes. When you put in an actual type, right? So right as we were reading through the summary, when you put in an actual type for the template's placeholder T, right? The compiler has its job to detect which template that you create and substitute it over there. The compiler does it. For instance, if the compiler cannot spot the actual one properly, cannot spot the template properly, right, with the type that you wrote in your script during compile time, it's not going to throw out an error, but it's going to use this phenomenon which is called substitution failure is not an error. I hope that makes you understand and clarify, makes everything solidify. Instead, if the substitution fails, instead of throwing an error, the compiler silently skips this template and looks for another one that works. That's basically the gist. Why is this useful? Substitution failure is not an error, is useful when you want to write multiple versions of the same template and let the compiler decide which one to use, okay? Based on the type of the arguments or the properties of types, right? It is often used to enable or disable certain functions or features depending on the types that are passed to a template. This is a powerful mechanism for template metaprogramming and allows you to create more flexible and type-safe code. Okay, so it's going to give you an example, but I just want you to understand that how awesome this tool is, right? When you create more than one template, we didn't look at the phenomenon of why we would need more than one template, right? Because you already have one that you use universally. But remember when we use template specialization for a chart, right? And it's to determine whether it's case insensitive, and then it just returns a response. But it's useful when you write multiple versions of the same template and let the compiler decide which one to use based on the type of the arguments or the properties of the types. Okay. It is often used to enable or disable certain functions or features depending on the types that are passed to a template. This is a powerful mechanism for template programming. Metaprogramming allows you to create more flexible and type-safe code. Well, how does it work? Let's break it down with examples. So we're going to look over this example, but before that, let's just see if there's any questions. All right. Yeah, I see Yasin's here. Yeah, I mean, we have Mom Lift Car, we have Snowball. Hey, bro, you're better looking than I thought, not gonna lie. Okay. Yeah, thanks. Yeah, so if there's any questions, just let me know in the chat. We're still going through it. Just keep let me know what you need asked, and so I'm gonna provide the response to it. Yeah, a simple function overload with SFINAE. Now, this is our example. What we have to do here, imagine we want to create a template function that works only for integers and another one that works for floating point numbers like this. So now this is the thing over here. We might want to include, a simple function overload with SFINE. Okay. Now, remember the concept of function overloading and function overriding? This is a video that I've done in the past in this channel. But tell me the difference between two. You can put it in the chats if you know it. So function overloading is basically the concept where you have a single function like add, int add, right? When you have a function to, add sum or sum, and you have two numbers, and it has, let's suppose, parameters a and b, right? And it returns the sum of it. And then you have another function, sum function, right? But it has three parameters, a, b, and c. You're basically overloading it because that name is the same. It's called sum function. But one function has two input parameters and the other function has three input parameters. You understand? And then when you write it and you pass in three arguments, when you run in compile time, it's going to check which function you're referring it to, right? So that's function overloading. Whereas function overriding means the function is same, the name is same, and is more depending on like inheritance. If it's on the base class or the derived class, and which function are you referring it to, right? So that's overriding the function, where it's like when you create a class called shape, and then you create a class called triangle or square. And then in the base class shape, it has get area, but for a generic class, what does it mean by area, right? And if you look at derived class get area for a triangle, what is the area formula for a triangle? Half multiply base multiply height. So essentially what you do when you create an object of triangle, right, you would basically override the get area function. That's called function overriding. I just gave you the brief gist of it. You could look and research online. But yeah, what is a simple function overload with this this concept, right? Substitution failure is not an error. Okay. Imagine we want to create a template function that works only for integers and another one that works for floating point numbers like this. So yeah. What am I going to be doing here is I'm going to say, okay, we have an IO stream. We have a type traits needed for standard enable if. This function is enabled only if t is an integer integral type like t type. So we have template type name t, type name enable if. Okay, I'm gonna make this more simpler for you guys. Print type t value, and what is this? An integer type. This function is enabled only if t is a floating point type like floating double. We have another template, template special. What's it called? A template, label or thing. So just like how it's called over here, yeah? So yeah, template declaration. Make sure we understand this. So it's called a template declaration. Let's just make it highlight. Template declaration, right? So let's go back here. So you can see over here template declaration here and then template declaration here. Okay, and this is the disabling functions based on type. Okay, but this one, what is it? A simple function overload with this, But this is a template declaration here, and that's template declaration here. Okay, and then you can see the type name over here. Type name is over here as well, right? And I think I could see something similarity here, like enable if. If you look over here, standard is integral, and then integral, and then over here is floating point. Okay, there's a difference here. Is integral is, I think it's part of integers, and this floating point is part of floating point, right? So we have, after that, we have this angle bracket t, which is the placeholder values over here, and then we have void, right? And then we have type. So we have print type t value and print type t value. So value is an integer type, right? And then print type, and then we have a print type value is a floating type, right? So we have print type 5 and we have print type 3.14. Calls the floating point version, which is right here, and calls the integer version. Oh man, this is so simple. This is actually super simple. Explanation. Let's read through the explanation, and then we'll talk about what we're actually looking at. So what we're here is the standard enable if. Remember, you saw this enable if, standard enable if, right? What is this? This is a type trait that acts like a switch. It enables or disables a template function based on a condition. Okay, it's like a switch. Oh, needed it for enable if. This is the type traits header file that you need for enable if. Okay, and then after that is integral, and then we have the parameter, and then we have colon value. This checks if t, which is the placeholder, is an integral type, meaning long. Okay, so an integral type is basically an int or a long, new information, right? If t is an integral type, the first function is enabled. Oh, okay, wow. So if it's an integral part, meaning like it's a 5, or if it's like a long or it's an int, then the first function is enabled. And then we have standard is floating point, and then we have value, right? So this also has a template. This checks if t is a floating point. So again, it just has one single placeholder. That means we just have to put one single value. 3.14 is a pi value, right? And we put it inside this, right? We put it inside this integral, sorry. We put it inside is floating point, right? This checks if t is a floating point type, like float or double. So floating point type is generally, what I'm saying is like float or double. Another general information is integral type, meaning is just for ints or ints or longs, whereas is floating point is more of like floats or doubles, right? If t is a floating point type, the second function is enabled. When we call print type 5, which is right here, print type 5 calls the integer version. When we call print type 3.14, it calls the floating point version, right? The compiler tries to substitute t with int in both templates. Okay, the compiler tries to substitute t. So this is what's happening behind the scenes with the compiler. You put in 5, the compiler tries to substitute the placeholder t with both. The compiler tries to substitute t with int in both templates. So basically, it tries to use both of the templates. The first function succeeds because it's an integral, right? Value is true, while the second function fails, but due to this concept, which is substitution failure is not an error, no error occurs and the compiler picks the first function. Finally, we understand what this is. Substitution failure is not an error. Whereas in example 2, we have another scenario where we have disabling functions based on type. Substitution failure is not an error, allows you to exclude certain functions or features for specific types. For example, suppose you want to create a function that only works for non-pointer types, right? You can use a SFI and AE to prevent the function from being used with pointer types. Now, how are you going to do this? Now, look at this. We have again, type traits header file. This function is enabled only if t is not a pointer type. So this is a template, and this function is enabled only if t is a pointer type. Okay, there's 2 processes, and then we're going to go through it. This is, again, almost at the end of it. So let me know after this. I want you to understand it. I want you to respond back in the chats if you understand this properly or not, right? So Reddit Rewind says, can you ask ChatGPT to ask if to make it in real life concepts with program example with output? Well, that's what we're doing right now, right? Overloading means where parameter works according to the number of parameter and data type of variable and call the function accordingly. Perfect. That is exactly it. Function overloading is basically when you're having multiple different types of function names, like add. Let me repeat that again. Function overloading is basically you have one function name, like suppose add sum, right? Sum function. And you have one with 2 parameters, one with 3 parameters, one with 4 parameters, one with 1 parameter. How are you gonna get a sum with just 1 parameter? But you basically have different scenarios of that same particular function name. And the return types don't really matter. It returns a int or it returns a double. But what it means is like different combinations of the input parameters, and basically that's function overloading. Yeah, this is super cool. I agree as well. Mashallah, keep it up. Thank you. Okay. Let's go forward. So now what we have is disabling functions based on type. Now, what is this disabling part? I told you we could use SFINAE again for this particular type of concept. Before let me going forward, let me just check my inbox. I was expecting some kind of mail, but let's see. No, nothing so far. But yeah, disabling functions based on type. Now, what I'm going to be doing is I'm going to show you this example scenario. When we had this example scenario, but we had a different type, right? If If it's checking if it's an integral part, it would go with the function template over here. And if it was a non-integral part, meaning if it was a float point part, it would go through this one. But again, the compiler would check both of them, and it would fail one and go and check the other one. Again, when it fails, it's gonna substitution failure is not an error. It rings that concept, and it does the thing. Now again, over here is another different scenario where we have a template type name. Again, template declaration here, right? And then we have a type name. We have standard enable if. Again, standard enable if. Where's it coming from? This header file type traits. Inside of this, we have standard is pointer, t value, and then we have void type. Okay. Again, we have a standard enable if, and we have standard is pointer, t value, and we have void type. Okay. All right. So standard is pointer, is not pointer. You can see over here, standard is pointer, and then we have a one single placeholder, and then we have colon value. I want to make it ensure you understand. Again, there's another type which is void, and then we have colon type. But the thing is, I want to assure you that this has a negation operator right there, meaning if it's not a pointer type, right? What's going to happen? It's going to use this process t value, and it's going to say processing a non-pointer type, right? Value. It's going to basically put in the value, and that's it. Whereas in this part, it is a pointer type, and it's going to go and it's saying processing a pointer type. That's it. And it shows you dereferencing the value. It's going to show you the value output using character output, right? Character output. And remember, these are insertion operators and extraction operators. I believe these are insertion operators. When the angle brackets are this way, it's called insertion operators. When angle brackets are facing towards the variable, it's called an extraction operator. Again, you can Google search quick insertion operator C++, and that's what I said. It goes outwards. So let's see what it does. Yep, it goes outwards. That's what I was saying, right? So basically, it's this way, and extraction is the other way. Okay, processing a pointer type. Again, we have a is equal to 10, and then we have a variable. Okay, we put in the stack. Then we get the address reference. We get the 0x hexadecimal value. We put inside of a pointer. Now a pointer to int, and it's a pointer to int, and it's called a PTR, and it stores the address of this data type. You understand, right? It basically, this thing has the address reference. Now what you want to do is when you want to dereference it, you could basically see the value 10, right? But when you just display PTR, displaying PTR will just show you the address of the value. But when you dereference it using this thing, it will give you the value, right, what it's pointing to. So call it the non-pointer version. Now look at this. When we have a value, we're just passing in process. Remember, this is the process function over here, a process function over here. When it fires both of these template functions, and it checks which one is a pointer and which one is not. In this case, it's not a pointer. Call the non-pointer version, which is up here. And in this case, it will call the pointer version, which is right here. Explanation that just gives the first function is enabled only if t is not a pointer, which is the placeholder, and again, it's true. The second function is enabled only if the placeholder t is a pointer, which is that true, right? Is pointer. Based on the type passed to the process function, the appropriate version is called for non-pointer types like int, right? The first function is called, and for pointer types like int asterisk, the second pointer is called. Second function is called. Okay, this is how substitution failure is not an error helps you control which template function gets instantiated based on the type. Again, there's a lot to go through, but it just keep giving more and more information, and this is what's amazing about it. Yeah, why it's called substitution? Wait a minute. We were here. Okay, why is it called substitution failure? The name substitution failure is not an error. It comes from the fact that when the compiler attempts to substitute a type into a template, trying to use t in enable if, and this substitution fails, example, the condition is false, which is over here. Remember these conditions that we have inside. If the condition becomes false, what happens? It doesn't throw out an error, right? So, and if the substitution fails, the compiler doesn't generate a hard error. Instead, it quietly moves on to look for another possible template match, right? Without SFINAE, substitution failure would cause a compilation error, and your program would fail to compile. Exactly. If you didn't have SFINAE, these things wouldn't even run, and you would have compilation errors. So when is it used? Enabling or disabling functions, when you selectively enable or disable certain functions based on the type or properties of the types passed to them, right? When you want to enable or disable a certain type of functions, generic functions. Type checking is often used where this thing is often used to detect certain properties of types, like whether a type is integral, floating point, or pointer. Template metaprogramming is a key. It's a key tool in writing complex template code, especially when working with libraries like Boost or C++ standard library. Okay, template library. Overload resolution. Now we have SFINAE allows the compiler to choose the correct overload. Okay, what is overload resolution? Allows the compiler to choose the correct overload when there are multiple template functions that could be matched based on type conditions. So overload resolution is basically allowing the compiler to choose the correct overload when there are multiple template functions that could be matched based on the type conditions. Overload resolution, and then we have template metaprogramming. It's a key tool in writing complex template code, especially when working with libraries like Boost. Yeah. Another use case of SFINAE is what is it saying? For detecting functions, right? Another example. You can use SFINAE to detect if a type has a certain member function. For example, let's write a function that checks if a type has a size member function. Okay, type has a size member function. Now this is a little bit extra, but you can see over here, true, false, and true. Has size, and we have a vector. Oh, okay. Oh, okay, that's awesome. Essentially, what you're seeing here is that we have a vector passed in, and we're checking if it has a size function, and it returns true. And then we pass in an int, just normally, and doesn't have any, right, size function. And then we pass in a string, and it has a size function. So basically, this template type traits, and then vector and string, detective a string as a size method. Then we have a template declaration, and we have a class has size, private, and then we have public section where we have a constant bool value type. Okay. If check int is valid, if we can use standard true, otherwise we can use standard false type. So yeah, again, it gives you so much flexibility. Now you could basically check if detect if a type has a certain member function, right? If any kind of type like vector, a string, or even an int has a certain member function like size, right? This is a size function that was being tested here. And this is actually very amazing. Summary, SFINAE allows the compiler to handle template substitution failures silently without producing errors, right? An error. It enables you to write specialized versions of template functions or classes that work only for certain types or under certain conditions. And it's commonly used to enable disable functions, check type properties, and make your templates more flexible and type safe. Okay. If you have any questions, throw them in the chats. We're almost about to conclude our live stream. If you have any more things you want to quickly ask, you could write it down in the chats. I'm going to be reviewing them right after I'm done reading this. And yeah, hope you like this live stream. And let me know what type of live streams you want in the future. Let me know, some topic suggestions. I'm going to put in community posts, but I want more responses, more comments, right? The person who, why am I even talking about this type of topic, SFINAE? Because I had a single comment of a person who wanted to review this topic, and that's why I created a live stream about it. So it's all up to you guys. The more you guys comment and the more likes it gets, I'm going to choose that topic and we're going to be talking about it. So this is what we're going to be trying to do from this time moving forward. We're going to be trying to do weekly live streams, and we're going to try to build our programming knowledge, right? Yeah, so it enables you to write a specialized versions of template functions or classes that allows only for certain types or under certain conditions. Yeah, basically, it allows you to do this. is a crucial part of template metaprogramming and allows C++ templates to be highly adaptable, creating code that can react to the properties of types that are used. So that was pretty much it. Let's go back here. Logan Paul, thanks. Yeah, I believe that's it. I'm about to, turn off the live stream. But if you have any follow-up questions or anything you want to ask, you could. I'm about to conclude it. I'm about to conclude the live stream. Yeah. React. Okay. So start a Q&A, answer viewer questions live, start a poll that your viewers weigh in. I don't know how much you guys are watching, but yeah, let's start a poll over here. Ask a question and add options. Okay, add option. Okay, what? Okay, so say, what kind of question can I ask? I don't want you guys to cheat, but what is the size of an integer data type in C++? It's very simple. I really wish I could remove this yes or no, or maybe no. I really want to remove that. Add option, add option. Wow. Okay, so I'm gonna put in 8 bytes, 2 bytes, and then I wish I could add 4 bytes. Oh yes, $bytes, 4 bytes, and then we have, suppose one more is, let's say 3 bytes. Or sorry, we had 2 bytes. Let's say 1 byte. Okay. Okay, let's see. Start poll. How this works. Okay, so this is my question, and put in your answers, and we'll see how many people get it right. Okay, I hope you guys could see the poll. Put in your responses, and I'll tell you the answer right after we conclude it. In the meantime, let me grab a juice, but you guys could fill in this. Okay. I don't even know if this was answered, but I wish we got sponsored. I'm getting juice from Ocean Spray, Cranberry. Hope we get some sponsors soon. I think no responses, so we're going to be ending the poll. The answer is 4 bytes. No one even responded. Yeah. So the answer was 4 bytes of computer memory. And yeah, looking forward to another live streams in the future. Let me know what topics you want. I'm going to be providing posts, and you got to make sure you comment down below what kind of topics should we discuss every week forward. So yeah, keep coding, keep programming. Thanks. Peace out.